Hey everyone, welcome back. Are you ready to take a deep dive with us?
Absolutely. Let's get into it.
Today we're tackling a figure who kind of needs no introduction, but we'll give him one anyway. Archimedes.
Archimedes,
Yeah,
a true titan of the ancient world. I mean, just saying the name conjures images of, well, eureka moments and incredible inventions.
definitely. He was this mathematician, inventor, physicist, the list goes on. And somehow he managed to excel in all of these areas. Plus, his work still has a huge influence today.
Which is incredible when you think about it. We're talking about someone who lived over 2,000 years ago. It really speaks to the enduring power of his ideas.
It's amazing to think that this guy's image is on the Fields Medal.
Mm.
Talk about a lasting legacy.
Right. For those who don't know, the Fields Medal is like the Nobel Prize of mathematics.
Exactly. It's the highest honor you can get in the field.
Yeah.
And Archimedes is right up there, recognized for his groundbreaking work in geometry.
Which is interesting because when you think about Archimedes, you don't just think about him being secluded, pondering shapes and proofs in some ivory tower. This was a guy who got his hands dirty, you know?
Yeah, and I'm not just talking about the whole bath and buoyancy thing, although we'll get to that later, don't worry.
Oh, we will. But first, we have to talk about Archimedes the Defender. This guy helped save his city from invasion using his inventions.
It's a side of him that doesn't get talked about enough. We're talking about the Siege of Syracuse, this incredibly dramatic moment in history. The Romans are attacking, the stakes are high, and here comes Archimedes putting his mind to work to defend his home.
And it wasn't just brainstorming sessions with the generals. We're talking about Archimedes actually designing and building these incredible war machines.
Right, like those giant catapults that could hurl massive scones at the Roman ships. Can you imagine seeing that in action?
It would have been terrifying. And then there was this claw thing, the claw of Archimedes, which could literally pluck ships right out of the water.
The Claw of Archimedes. Seriously. Okay, now I definitely need to hear more about this. What did it look like?
Well, from the descriptions we have, it was this huge crane-like arm that could reach out from the city walls. They would lower it onto enemy ships, hook onto them, and then, well,
Go on.
they would basically flip the ships over or smash them against the rocks. It was pretty effective. There are even accounts of Roman soldiers being so terrified of this thing that they wouldn't even sail near the city walls.
Darn, talk about psychological warfare.
Huh.
And I've heard rumors about some kind of death ray situation. Mirrors reflecting the sun to set ships on fire. Is any of that true?
The heat ray. It's a popular story, that's for sure. It has captured imaginations for centuries. But the historical evidence is a bit shaky. There's no definitive proof that it ever actually happened.
I figured as much. Still, it's a cool image. It really speaks to his reputation as, like, the original mad scientist.
Oh, absolutely. Whether the mirrors were real or not, there's no doubt that Archimedes was way ahead of his time when it came to technology. Just think about the engineering knowledge needed to build those catapults and that claw.
It really makes you wonder about how the ancient Greeks viewed mathematics. We often think of it as this purely abstract field, but here you have Archimedes applying his knowledge to real-world problems with incredible success.
And not just any problems, we're talking about life or death situations. It challenges our whole perception of how theoretical knowledge translates into practical applications.
Right. It wasn't just some intellectual exercise for Archimedes. It was about defending his home, his people, his entire way of life. It's kind of mind-blowing when you think about it.
It is, and it gets even more mind-blowing when you consider some of his other work, like his writings on numbers, specifically really big numbers.
Oh, you mean the Sand Reckoner? That's what we're diving into next.
Right,
The title alone tells you this is going to be good.
Right. It sounds like a children's book, but it's actually this incredibly deep exploration of mathematics and the nature of the universe.
And it shows just how far Archimedes was willing to push the boundaries of human thought. He basically set out to calculate how many grains of sand it would take to fill the entire universe.
Which is ridiculous. I mean, it's such a crazy idea when you think about it. But that was Archimedes for you. He didn't let the limitations of common sense hold him back.
He was like, hold my abacus, I'm going in.
Exactly. And to be fair, this was a time when many people believed that the universe might actually be infinite. So Archimedes was challenging a pretty fundamental assumption.
It's like he was saying, let's not just assume. Let's explore this using math.
Mm.
And in the process, he ended up creating a whole new way of thinking about really large numbers.
Because, of course, trying to write out those numbers using the number systems they had back then would have been impossible. We're talking about numbers with like 80,000 zeros.
80,000 zeros. My calculator can't even handle that.
Yeah.
So how did he do it?
He invented a new system. He came up with this idea of using powers of a myriad, which is 10,000, to express these incredibly large numbers. It was a precursor to scientific notation, but centuries earlier.
So basically, he invented a whole new way of writing math just to tackle this one problem.
He was committed, I'll give him that. And it gets even wilder. To figure out the size of the universe, he used the heliocentric model, which is the idea that the Earth revolves around the sun.
Wait, that was around back then? I thought that was a Copernicus thing.
Copernicus gets the credit, but the idea was actually much older. Aristarchus, another Greek thinker, proposed it a couple of centuries before Archimedes.
Wow, I had no idea. So Archimedes was using this kind of radical, cutting-edge astronomy in his work. That's impressive.
Exactly. He used Aristarchus's model to estimate the size of the universe, and then he used his own system of large numbers to calculate how many grains of sand could fit inside.
So the sand reckoner wasn't just about counting sand. It was about pushing the boundaries of mathematics and cosmology at the same time.
Exactly. And it was also about something else, something that often gets overlooked when we talk about Archimedes. His desire to communicate these complex ideas to others.
He wanted to share his sense of wonder, to make these mind-blowing concepts accessible to everyone.
Exactly. He wasn't content to just sit alone in a room doing math. He wanted everyone to appreciate the beauty and power of these ideas.
Okay, that's actually really cool. It's like he was a teacher at heart, even while he was out there being a genius inventor and defender of nations.
He was a true Renaissance man, centuries before the Renaissance.
It's like he saw math everywhere he looked, even in, like, a bathtub. Which brings us to that famous story, the Eureka moment.
Ah, yes, the bathtub. You can't talk about Archimedes without mentioning the bathtub.
It's such a classic story, and it perfectly illustrates how his mind worked. Always making these unexpected connections, finding inspiration in the most ordinary places.
It makes you wonder what else we could achieve if we just paid a little more attention to the world around us.
Right. Right, like, what profound mathematical discoveries are hiding in my morning coffee?
Yeah.
Okay, but seriously, how does the story actually go? Remind us.
Well, the story goes that King Hiram II, he was the ruler of Syracuse at the time, had given Archimedes this problem to solve. It involved a crown that was supposed to be made of pure gold.
Ooh, a golden crown. Sounds fancy.
It was, or at least it was supposed to be. The king had given a certain weight of gold to a goldsmith to make this crown, but then...
There's always a but.
Right. But the king started having suspicions. He thought maybe, just maybe, this goldsmith had tried to pull a fast one.
Meaning?
Meaning he thought the goldsmith might have kept some of the gold for himself and mixed in a cheaper metal to make up the weight, like silver, for example.
Sneaky, but also pretty clever. I mean, if you're going to try and cheat a king, that's a pretty good way to do it.
It's not bad, except, of course, for the whole getting caught part. So the king turned to Archimedes and said, "Figure this out. Is this crown the real deal, or did this goldsmith try to trick me?"
Okay, I'm already hooked.
Yeah.
But this is Archimedes we're talking about. It's not like he could just, like, pop the crown under a microscope or something.
Exactly. And they didn't have those fancy modern techniques for testing the purity of metals back then. So Archimedes had a real puzzle on his hands. He knew that gold and silver have different densities, meaning if you have the same weight of gold and silver, the silver will actually take up more space.
Okay, that makes sense. So if the crown was partly silver, it would be a bit bigger than a pure gold crown of the same weight.
Exactly. But how do you measure the volume of something as irregular and ornate as a crown? That's where the bathtub comes in.
I knew it. I was wondering when the bathtub would make its grand appearance.
So the story goes that Archimedes was pondering this problem, really stressing about it, and he decided to take a bath to relax. You know, as you do.
Nothing like a nice warm bath to get those creative juices flowing, right?
Exactly. So he's lowering himself into the tub, and he notices the water level rising as he sinks lower and lower. And then, bam, inspiration strikes.
Eureka. See, I told you it was a good story. I can practically hear him shouting it from ancient Greece.
I know, right? It's such a great image. He realizes that the volume of water that is displaced is equal to the volume of the object submerged in it. So if he can figure out how to measure the volume of water displaced by the crown, problem solved.
Wow, that's actually brilliant. Such a simple observation, but it unlocks this whole new understanding of volume and displacement.
Right. And it highlights how Archimedes was able to connect seemingly unrelated ideas, taking something as ordinary as a bath and turning it into this profound scientific insight.
It reminds me of that Steve Jobs quote, "Creativity is just connecting things." Except, Archimedes said it first in ancient Greek, of course.
And probably while wearing a toga. But that's exactly what makes his work so fascinating. He constantly blurred the lines between the abstract and the practical. He saw connections where others saw only separate fields of study.
It's like he saw the world as this big, interconnected web of knowledge, and he was constantly weaving new threads between different disciplines.
And that's especially apparent in his work, The Method, where he actually lays out his thought process for us. It's like we get a peek inside the mind of a genius.
Oh, yeah. The method. I've heard about this. It's like
Yeah.
his personal playbook for problem solving, right?
Exactly. And what's remarkable about The Method is that it reveals how freely Archimedes moved between different fields of study. In it, he describes how he used mechanics, basically the principles of physics, to help him understand and solve problems in geometry.
Wait, hold on. He was using physics to solve math problems. That's next level. I
Yeah.
could barely balance my checkbook.
He was playing a different game, that's for sure.
Yeah.
Back then, the prevailing approach to geometry, especially following Euclid, was all about logic and deduction. You started with these basic axioms, these self-evident truths, and you built your proofs from there. It was very rigid, very structured.
Like building a house brick by logical brick.
Exactly. But Archimedes wasn't afraid to think outside that very structured box. He was like, what if we bring in some tools from the physics world? What if we use our understanding of levers and balances and forces to help us crack these geometric codes?
So instead of just using logic, he was using like imagination and intuition. I mean, he was picturing these physical objects and how they would behave.
Exactly. He would visualize these thought experiments, these what-if scenarios, to guide his thinking. And you know what? It worked. He talks in The Method about how he often reached his initial solutions through these mechanical thought experiments, and then he would go back and prove them rigorously using more traditional geometric methods.
So it was like he was using mechanics as a shortcut to mathematical truth. That's amazing.
It really is, and it completely challenged the way people thought about math at the time. It was like he was saying, hey, there are many ways to reach the truth, many paths up the mountain of knowledge.
And he wasn't afraid to forge his own path, to use whatever tools he had at his disposal. It's inspiring, really, and kind of intimidating. I mean, this guy was operating on a whole other level.
He was a one-of-a-kind genius, that's for sure. But that's what makes studying him so rewarding. He challenges us to think differently, to question our assumptions, and to never stop exploring the connections between seemingly unrelated ideas.
It's like he was playing jazz with math and physics, just riffing, improvising, and coming up with these incredible melodies of thought.
And like any great jazz musician, he knew how to bring it all back home, to ground those improvisations in solid theory and rigorous proof.
He was the real deal, which makes it all the more tragic how his story ends. I mean, we can't talk about Archimedes without talking about his death, right?
No, we can't. It's a story that's almost as famous as the Eureka moment, and it's a stark reminder that even geniuses aren't invincible.
It's one of those stories that kind of makes you shake your head and say, really? That's how it happened.
You're talking about the Siege of Syracuse again, of course.
Right, the Romans finally captured the city, despite Archimedes' best efforts.
It was a long siege, but the Romans eventually found a way in. And according to the story, Archimedes was so engrossed in a mathematical problem that he didn't even notice what was going on around him.
I've heard that. Like there were soldiers bursting into his house and he was just like, don't disturb my circles.
That's the most famous version of the story, yes.
Hmm.
And whether those were his exact words or not, it captures the intensity of his focus, his complete absorption in the world of ideas.
It's almost like math was its own world for him, a world he could escape into. But sadly, the real world has a way of intruding, sometimes violently.
It does. And in Archimedes' case, that intrusion proved fatal. A Roman soldier, perhaps not understanding who he was dealing with, or perhaps not caring, killed him.
It's a tragic end to a brilliant life. And makes you wonder, what else could he have accomplished if he'd had more time? What other problems could he have solved? What other connections could he have made?
It's impossible to know, of course, but it does make you think about the fragility of knowledge, of how easily it can be lost. And it highlights the importance of preserving and passing on that knowledge, of making sure that these sparks of genius aren't extinguished.
That's a good point. It's like that old saying, when an old person dies, a library burns down. Except in Archimedes' case, it was more like a whole university went up in flames.
A real loss for humanity. But even though he's been gone for centuries, his legacy continues to inspire. And that's really the most important thing, isn't it? That we keep his memory alive, that we continue to learn from him, and that we strive to approach the world with the same sense of wonder and curiosity.
Absolutely. He reminds us that the pursuit of knowledge, the joy of discovery, these are things worth fighting for, worth dedicating our lives to.
He shows us that even seemingly impossible problems can be solved if we're willing to think differently, to challenge our assumptions, and to never stop asking, what if?
Well said. So to everyone listening, we encourage you to go out and explore Archimedes for yourselves. Read the Sand Reckoner. Dive into his inventions. Let your imaginations run wild.
Because who knows? You might just have your own eureka moment along the way.
And that's what it's all about, isn't it? That spark of discovery, that moment when the world opens up and reveals its secrets, that's the legacy of Archimedes, and it's a legacy we can all share. Until next time, keep those minds curious and keep diving deep.